Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to create constructors. So this is the class we created in our previous demo, and what we have is we have some fields defined, we have uh, an accessor and a mutator defined, and we have a default constructor or a parameterless constructor defined. So the first thing we're going to do is add some more accessors and mutators to this class. And I've already written them, so I'm just going to paste them in. There isn't much change in functionality, or in at least the way that we built them from the last demo. So rather than repeat that, we'll just put them in. And what you can see is we have each of our fields have an accessor, and each of our fields also have mutators in this class. And all we're doing with these are retrieving the fields through our accessors, and then in our mutators we're taking in one parameter, which is the new value for our mutator for our field, and then the mutator just assigns that new value into that field. This way we can keep our fields private, and these accessor and mutator functions will be how we access, or methods are how we will access those fields. The next thing we're going to work on are our constructors. So we currently have a default constructor. We're going to improve it a little bit by adding some initialization code. And what I've done here is I've taken our fields, they're located at the top, and when you instantiate a new student, this parameterless constructor will set some safe values into student number, first name, last name, and major. And you could imagine that this is what perhaps a business might have some business rules that they would want you to implement. So the next thing we want to do is test this constructor out, and what we're going to do is instantiate a new student, and use some console.writelines to display the data. And we can see that when I put the identifier for the student object and hit the dot operator, I get all my mutators and accessors available. The gets are the accessors, the sets are the mutators. And so we're going to want to get the student number. And it's a method, so I have to have parentheses. And again, I've got a get for first name. And it's interesting, you can see that with IntelliSense, here's the class I wrote. It tells me what type of object it returns. It returns a string. So that can be useful in writing your code and debugging it. And so we'll instantiate a student. We haven't specifically set student number, first name, last name, or the major. But we're going to see that this constructor will actually initialize all those values. So I hit Control F5 and I run it, and we can see, yes, in fact, pending TBD, TBD undeclared. Those are the values that are initialized by the constructor, and those showed up in our output from main. So that's how a constructor works. It allows us to initialize some values, and this way, if I created multiple students, they would start off with all the same types of initial values. We're going to run this again, but this time we're going to run it in debug, and so I'm going to establish a breakpoint at the start of the program and run in debug mode so we can see how this jumps through the different methods. So we're in debug mode. This is the beginning of the program, and just so we can watch what's going on at the same time, so we're at the top. Nothing's happened so far. I'm going to press F11. F11 allows us to step into each step of the program. And we can see down here my student currently is null. So we have a space of memory called my student. It hasn't created anything yet. When I press F11 one more time, it actually jumps now to the constructor. This new student actually calls the constructor, and when I jump through the constructor, we now see that student that it starts assigning values to each of our fields. So student number is assigned, then first name is assigned, then last name is assigned, and then the major is set to undeclared, and we're done with the constructor. It jumps back to main, the calling function, and we continue execution. Now when we write line, we can see it calls the get. This returns student number to the calling method, which is then passed to writeLine, which then displays it to the user. And so we can see how we're jumping back and forth between the calling method and these accessor and mutator functions inside of our class. And that's how we can use this class to do work. Now the next thing we want to do is often we want multiple constructors because there may be different ways someone using our class may be able to initialize. We want to provide them different ways for them to initialize our class. And so we're going to add some overloaded constructors. And the way we overload constructors is basically we use different parameter lists. And so we'll add a single parameter constructor. It takes one parameter and sets the student ID, but sets everything else to what we had before. We'll create a two parameter constructor. and we'll add this large overloaded constructor which sets everything. Then within main, we're going to test out that large overloaded constructor, and we can see here that we're initializing the student number, the first name, the last name, the initial scores, and the major. And we'll display some of those values just like we did before. I'm going to run it with Control F5. And in point of fact, we see that all these values that we passed to this overloaded constructor are now set into our object. Now, one of the disadvantages of this approach is it doesn't really apply the dry principle, the do not repeat yourself principle, very well, because we can see here we have a lot of code which is replicated. One of the things that we have available to us in C# are construction initializers. And basically, in order to use a construction initializer, what we do is we can use the this keyword, which references to the object that in question for this class, and rather than setting these values down here, we can pass them in as arguments to this initializer. And the advantage is that the way this works is if you call the parameterless constructor student with no parameters, it will come into here and then it'll run the constructor which meets the parameter list requirements over here. So it'll actually jump down to this large overloaded constructor here, and it'll actually then pass number into, or number pending into the student ID, TBD to first name, TBD to last name, the -1s to the score, and then undeclared to the major, and then this overloaded constructor will actually do the initialization. And so the advantage of this is that we have the code now defined in one place. And if we need to maintain it, then we don't have to replicate code changes throughout the code base. We only have one place to have to make a change, so it increases maintainability. So now if I make a change to how we initialize things, I can do it down here and it will replicate throughout all of our constructors. And if I run this first off just with Control F5, I see that it works the same as it did before. If I run in debug mode, we can see how this jumps back and forth. So I'm going to press F11 and step through this code. So first it calls So the next thing we're going to do is test this out. I'm going to go back to the default constructor and first run it with Control F5. And we can see that just like we did before, call in default constructor set everything to pending, TBD, and undeclared. If we run it in debug mode, we can see how this will step through and jump back and forth throughout the different methods of the classes. So I started in debug mode, we hit the breakpoint, and now I'm going to step through with F11. First it calls the constructor. Student right now is null. It needs to instantiate a new student, so it calls the default constructor. Now that we're in a default constructor, I'm going to hit F11 again, and we can see that execution jumped down from the default constructor, or the parameterless constructor, down to public student. And you can see that SID is equal to number pending, which came from here. We can see that first name is TBD, which again came from that construction initializer. Last name is also TBD, and each of these values was initialized through this construction initializer. We step through, each of our fields are now being assigned the values from the parameterless that was passed from our parameterless constructor through the construction initializer to our parametered constructor. All the values are established. Execution returns to the constructor which called it. And now we'll execute any code. If there was any code inside of the constructor that was left over, it would actually execute through all of that. And then it comes back to main, the calling method, and continues execution in main. Now it goes through and uses our get statements so that it can do its write lines. And we get all our values displayed in the console window. So that's how we can use a construction initializer, and it will jump execution back and forth through the various constructors. This improves maintainability of our code. There's a little bit of extra execution that happens because it is making an additional function call, but it doesn't affect execution speed that much. The last thing that we'll demo is destructors. So a constructor instantiates a new object. A destructor will actually is executed during garbage collection. And one of the nice things about C# is that garbage collection is done automatically, which means that we don't have to write specific destruction code normally for our classes. But if we do want to change the way or affect how things are impacted when an object is destroyed, we can use a destructor by using a tilde in front of the name of the class. That is how we define our destructor method. And in this case, all I'm going to do is just write a message to the console that tells us that the object is no longer in memory, has been essentially the data has been destroyed. So student data no longer in memory. We're going to concatenate in the student ID so that we can see that we can actually access all of the class members just before destruction. So this allows us to make changes, or typically you'll actually implicitly write a destructor when you actually need to release some kind of resource that you may have gotten in a constructor. So in this case, we're just going to display a message. So if I run this program with Control F5, what we see is we now get an additional message. It says student number pending, data no longer in memory. And so because we don't have a number yet and we use the parameterless constructor, we get pending data as far as a student ID. But that tells us that it instantiated, it created it, and now it ran this destructor just before the garbage collector removed it from memory. The garbage collector, by the way, doesn't automatically run when your class is done. It typically runs when there's nothing in your code that references that class anymore. After that, it's placed on a queue, and then when the garbage collector gets a chance to, it runs through and releases all of those objects. So you can't really guarantee when a destructor will necessarily be run. Another aspect of destructors, I'm going to comment this code out, is there's a finalize method, and every object has a finalize method, and so in theory you should be able to override that finalize method, and we might try to override that finalize method in order to do much the same thing as we just described there. And typically you might do something like this. You might create a try block, and you might add some cleanup statements here. And you might call the base finalize method. Well, if I try that, it actually gives me an error. It says don't directly call your base class finalize method. It is called automatically from your destructor. So in general, we don't override the base object class's finalize method, and this doesn't typically work very well. You could if you didn't call the base finalize method and you did this, there's no guarantee that your class will be properly destroyed, and that might actually cause a memory leak. So generally speaking, we don't mess with the finalize method, and we let C# manage destruction. But if we do want to have some last minute things done, then just create a destructor method and do your work within that destructor method. This completes my demonstration of constructors and destructors. Thank you very much.